Hello, another quick guide to another statistics topic. So interpolation. So this is linear interpolation. So linear interpolation assumes that your frequency is equally distributed inside the class interval or the class width. So I just want to go through and talk about how you can use interpolation to find things like 30th percentiles, 70th percentiles, medians. It doesn't matter whereabouts you want to be. You can try and use linear interpolation to find all these values. So what we're looking at currently is continuous data, and it's equally kind of, as I say, we're going to assume that these are equally distributed in each class. So for part A, so first of all, we've got frequency distribution shown in this table. So from 1 to 10, we've got a frequency of 10, 11 to 20, a frequency of 20, and so forth. The first thing that stands out to me in this table are the class intervals themselves. So 1 to 10, for example. The first kind of question that sticks out to me is, where would a value like 10.5 go? So these need updating straight away. These are no good to us. So we need to update these, which I'll try and squeeze in at the top. So that's going to be my first job, is just trying to update those. So let's have a look at what these can be. So 10.5 is actually in between 10 and 11. That's going to be the boundary of this, so 10.5. Obviously, when it's equal to 10.5, it'll go in the second category. When it's less than 10.5, it'll go in the first category. And likewise for the lower bound of this would be 0.5. The first thing is to set up the bounds. Technically speaking, we could write these with the little x involved, and it'd look like this. I'm not going to do this for each category though, just to make it a bit faster. I'm just going to put the midpoints in. And then that'll help me figure out how wide these bounds actually are, or these classes. Okay, so the idea of interpolation, there is a formula for it that a lot of people use, but I try and use a little bit of logic. So I'm going to use, I'll show you using the kind of idea that I use to work this out. So using interpolation to estimate the value of the 30th percentile. So the 30th percentile is where the 30th kind of percent of the data lies. So the frequency, we've got all of these, which I need to work out, but that's 100% of my data. So if I add these up, I've got 10 plus 20, should really do this in my head, plus 30, plus 24, plus 16. So we've got 100 values. That makes this a lot easier to work out. So let's just put 100 there. The 30% of all of these values, so the 30th percentile here, would be the 30th value. So this one's really kind of straightforward to work out, not really interpolation here at all. So the 30th value here, up to at this point here, we've got no values. So at 0.5, there's no values. At this part here, we've had, so this is the end of the class, there's 10 values. So up to this point, we've had 10 values. Up to this part, we've had another 20. So in total now we've had 30. And this is almost like my cumulative total across the bottom that I'm just doing, just so I can see whereabouts these values are taking place. So for the 30th percentile, I want to find 30% of the total frequency. So 30 out of 100 times by 100. So clearly that's just the 30th value. And remember, this is the 30th value. It's not the number 30. I'm looking for the 30th value, which you can clearly see takes place on this boundary. So this is simply just 20.5. As this implies 20.5. So that's the 30th percentile. Let's just call that P30. In part B, we're looking for the 70th percentile. So we're looking for 70% of the data. Normally we get worse numbers than 100 here, but it all works the same. So I'm looking for the 70th value here. Now this one's much better. So we had the 60th value at the start of this category, and at the end of it, we had 84. So the 70th is somewhere in here. It's not quite midway, because that would be 72. So it's kind of, oh, what did I say? 72, that's wrong. It'd be, yeah, 72, yeah, midway. So it'd just be slightly before that. So it's about here. So if we imagine spreading these equally about, where we're looking for about the 70th value, which is about here. The way that I think about this is so this category itself, we want to go into this. So from 60 to 70, we want to go 10 into this category. So we want to go 10 spaces into this category out of a possible 24. So there's 24 values in here. We want to go 10 into that. So the way that I'd work out the 70th percentile is I'm going 10 into this category out of a possible 24. And I want to times that by the class width. So from 30.5 to 40.5, that class width is 10. That will tell me how many to go into this category. But remember, this category itself actually starts at 30.5. So when I work out how far this actually is along in the class interval, I need to remember to add on to that my starting value of the class width, so 30.5. If I put this into my calculator, that will tell me my 70th percentile. So 10 out of 24 times by the actual class width here, so which is 10. That gives me 4.1666. So it's telling me to go into this category by 4.16. So when I add that to the starting category, 30.5, I get 34.6 recurring. So 34.66, which I'm going to round to 34.7. So that's my 70th percentile. Final part here is the interpercentile range. So between the 30 and 70th percentiles. So here I'm going to do P70 minus P30. So remember, inter means between. So this is between the two percentiles. So it's a difference. So I'm just going to do a quick subtraction there. So 34.7 minus 20.5, which is 14.2. And that's that particular question. I'm just going to add to this a little bit if I wanted to say find the 50th percentile. So in other words, the median. So I'm just going to add that here. So find the median just as an extra little bit. If I wanted to find the median, that is what we call Q2, or which is the 50th percentile. So whatever you want to call it. So I want 50% of the data. So half of 100 is the 50th value. So I'm looking for where that occurs in this data. 30th here, 60th here. So it's kind of in between these two. Exactly in between here would be 45. So we know it's slightly off and it's about here. So there's about the 50th. So to get from 30 to the 50th value, I need to step into this category 20 places. So the difference between 50 and 30 is 20. Out of that category itself has 30 different people or different numbers in there. So that's 20 divided by 30. The width of this category is 10. So from 20.5 to 30.5. And then of course, to find the last little bit, I need to remember I started at 20.5. So I'm going to need to add that on. So I just have to calculate that. So 20 times 10 is 200 divided by 30 and then add 20.5. I'm just pressing equals. So that gives me a value of 27.16, which again, I'd just round to 27.2. So that would be the median for this value, for this piece of data. Hope that helps with interpolation. If you need any more help, just let me know.